In this video, we're talking about how to find the center and radius of a circle. And in this particular problem, we've been given the equation x squared plus 2x plus y squared equals 4. And we know that this equation represents a circle because we have an x squared term and a y squared term. So the easiest way to find the center and radius of a circle is to transform the equation so that it's in this form here. Quantity x minus h squared plus quantity y minus k squared is equal to r squared. Because in this form, we can say specifically that the center of the circle is at the coordinate point hk, and that the radius of the circle is r. So if we can get our equation into this form, then we can just pull out values of h, k, and r and give the center and the radius. So how are we going to transform this equation into this form here? Well, what we want to do is complete the square with respect to both x and y, because notice that we have this quantity x minus h squared and quantity y minus k squared. If we were to expand those, for example, if we expanded x minus h quantity squared, what we would get is x squared minus 2xh plus h squared. And this can be factored perfectly into quantity x minus h squared. So we need to complete the square with respect to x and y. So if we look at x first, here we have x squared plus 2x, and we can even just rewrite this. We'll say x squared plus 2x, we'll put parentheses around it. Then we have plus y squared is equal to 4. So dealing with the x terms here, what we want to do is take the coefficient on the first degree x variable, in this case that's 2, and this is the same process you're going to follow every time for completing the square. So we're going to take that 2, and then you're always going to take this value and divide it by 2. So the result here is going to be 1. Whatever the result is, we want to square it, so 1 squared is going to give us 1. This value right here is what we're going to add to x squared plus 2x to complete the square. So if we add that in, x squared plus 2x plus 1, keep in mind we also have to subtract 1 so that we don't change the value of this equation. We can't just add in 1 without taking it back out again. Otherwise, we would change the value of this equation. So we want to say plus 1, then we want to say minus 1, and we have our plus y squared equal to 4. Now what we have inside the parentheses here can be easily factored. X squared plus 2x plus 1 is the same as x plus 1 times x plus 1. Therefore, we can rewrite this and we can say quantity x plus 1 squared. Then we have minus 1 plus y squared equals 4. Well, we want to go ahead and add 1 to both sides to get rid of this negative 1. So we'll say x plus 1 quantity squared plus y squared is equal to 5 when we add 1 to both sides. Now for y here, the process of completing the square is really easy because y squared is just the same as quantity y minus 0 squared. So we can rewrite this as x plus 1 squared plus quantity y minus 0 squared equals 5. And we haven't changed the value here at all because y minus 0 is still y. Y squared gives us y squared. So we haven't changed the value, but now notice that this equation is in the same form as the formula here with the x minus h and the y minus k. So what we want to do is pull out values for h, k, and r. The most important thing to remember about this formula here, and let's go ahead and box these things, we have a minus sign right here and a minus sign right here. We have x minus h and y minus k. And that's really important because here, notice we have x plus 1. We can't just pull out 1 and say that h is equal to 1 because here we have x minus h, here we have x plus 1. We need to make sure that we have x minus something and y minus something in order to have an equation that matches this formula we've been given. So let's go ahead and rewrite this equation. Instead of x plus 1, we'll say x minus a negative 1 like this, so that we actually have x minus a negative 1 is x plus 1, so we haven't changed the value, and then leave that squared plus y minus 0 quantity squared equals 5. Now, because we have x minus a constant and y minus a constant, we can pull out values for h and k directly. So we can say here that h is equal to negative 1 and that k is equal to 0. So hk becomes negative 1 comma 0, and that's going to be the center of our circle. The radius is the value we're going to pull here from the right-hand side, but we have to again be careful because in our formula we have r squared on the right-hand side. We can't just say that the radius is equal to 5. We actually have to take the square root of 5 in order to get the radius. In other words, we're looking specifically for this value here of r, not the value r squared. So we could, instead of 5, we could rewrite this as square root of 5 quantity squared, because then we could compare this directly to our formula and we could pull out this value here of r as the square root of 5, because we have r squared here and we have r squared here. So in this case, we would say that r is equal to the square root of 5. Now you might say we have to indicate here positive or negative square root of 5, but in fact we don't, because we know we're dealing with a circle, and if the radius were negative square root of 5, we would have a negative radius, and it's impossible to have a negative radius and for the circle to still exist. So we're always going to look for the positive value of r, and therefore we can say that the radius is the square root of 5. And that's how you find the center and radius of a circle.